dy dt equal x squared plus 2y, and the initial condition was 1, 2. So they want us to first solve it and then use the nullclines to sketch the solution on the phase plane. So what type of problems do we have here? As you can see here, if you look at this equation here, this equation, the y is missing, and therefore what we have is a differential equation that involves only the first unknown x. So this system is half decoupled, and to approach it would be to solve first this equation, find x, and then plug it in this equation, the second one, and find y. And that's what we are going to be doing right now. So first, let us start by solve dx dt equal 1 over x, and of course we have the initial condition x of 0 equal 1 from the initial condition in the system here, and this one here. Great. So clearly this is a separable equation. It has no constant solutions because we have 1 over x is not equal to 0, and we are only left with what? Non-constant solutions. The non-constant solutions, we separate the variables and we get x dx equal dt, and then we integrate to find x dx equal the integral of dt, and this gives me x squared over 2 equal t plus c. So or x squared equal 2t plus c. It doesn't matter whether you have 2c or c, it's just a constant. Now, the initial condition x of 0 equal 1 implies x squared equal 2t plus 1, since c is equal to 1 squared, which is 1. So x of t is equal to plus minus square root of 2t plus 1, and since x of 0 is equal to 1 positive, then we only keep the positive 1, not the negative one. So x of t is equal to square root of 2t plus 1. Then we go to the second equation, because now we know what is x, so we go to the second equation, which is dy dt equal x squared plus 2y, to get dy dt equal x squared plus 2y, and y of 0 is equal to 2. So we need to solve this equation, this IVP, and again we recognize the linear equation, and therefore we go by u of t. So here first we look for the integrating factor, u of t equal e minus the integral of 2 dt, which is e minus 2t, and then we go for the general solution, which is y equal the integral of u of t times 2t plus 1 dt plus c over u of t, okay, or y equal 2t plus 1 e minus 2t dt plus c over e minus 2t. So here what we need to do is just to integrate 2t plus 1 e minus 2t dt, and for that we can use an integration by parts, and the answer will be minus 2t plus 1 over 2 e minus 2t minus 1/2 e minus 2t plus so again, this is an integration by parts where I integrated e minus 2t and differentiated. So I integrated e minus 2t and differentiated 2t plus 1. So this is just a simple exercise, calculus 2 exercises. Can leave to anyone to complete. So the answer is then minus 2t plus 1 over 2 e minus 2t minus 1/2 e minus 2t plus c over e minus 2t. Once we have done all the algebra, we'll find that the answer is minus 2t plus 1 over 2 minus 1/2 plus c e 2t. And clearly this will force a little bit more algebra. That's minus t and minus 1 plus c e 2t. The initial condition was y of 0 equal 2, so we get 2 equal minus 1 plus c, or c equal 3, which implies y equal 3 e2t minus t minus 1. Great. So the solution that we are looking for to the system, the solution is y equal square root of 2t plus 1 and 3 e2t minus 1 minus t minus 1. Now, in order to graph this one, they want us to do the nullclines to be able to graph it. It's not very hard to see that the x nullclines do not exist, since 1 over x is not equal to 0, so we have no x nullclines. Okay, and for the y nullclines, we get x squared plus 2y equals 0, or y equal minus x squared over 2. So this is for the y nullclines. Okay, so if we want to graph it on the phase plane, we get so we'll graph the parabola. So that's the parabola minus x squared over 2, or the y nullclines. If we take the arrows, we'll find that the arrows are like this here. Here is like this. Here is going to be going down, up, up, up. So, and here as well, up. So if we take the initial condition, which is 1 and 2, which is around here, then the solution is going like this, up like this. Okay, that's the blue one. Okay, thank you.